So we've talked about a number of different pump concepts, including types of pumps, pump components, the proper selection and design of pumps for the right application, and total dynamic head. And we'll complete our evaluation of the pumping concepts with a discussion on the operations of pumps and pump stations and some of the key components that we need to make sure we're familiar with or aware of. So we're going to start with just kind of the overall, as I've said before, whether it be with net positive suction head or certain other things, the manufacturer's recommendations are critical to the successful operation of a pump. So whatever the manufacturer says is the right application, deviate from that at your peril. So those are an important part of the operational plan for any pumping facility. We'll start with the concept of priming. Priming is simply the understanding that the impeller must remain submerged. In a flooded suction pump, it's always submerged, so there's no priming required. And when we say the impeller must remain submerged, we're simply saying the volute should be full of water. If the pump is located above the water source, however, then priming is going to be required. In a suction lift condition is really what we're talking about. So you got to make sure any trapped air is purged from the volute and that the impeller remains submerged. Now, there's a couple ways we can do that. One is a foot valve and the other is a priming pump, in some cases combined. So the priming pump is really a pump drawing water from the same source of water as the pump might to continue to maintain water in the volute to maintain that prime. The foot valve is simply a valve on the bottom of the suction pipe that does not, it's a check valve for all intents and purposes. It does not allow the suction pipe to drain. So it's a valve at the bottom that helps to maintain all the water in the suction pipe so the water can't drain out of the volute. And when we talk about valves in a couple weeks, I think we will talk about check valves then, but check valve is simply a valve that only flows in one direction. So it will allow water to flow into the suction pipe. It does not allow water to flow out. So it helps to maintain that pipe full and therefore maintain the prime. Starting and stopping pumps. This is really about avoiding surges and water hammer. There's a variety of different ways to do that. You can do it with check valves. You can do it with pressure relief valves. You can have surge tanks to prevent water hammer on the system. You can have a control system that's designed to start and stop the pump in kind of a ramped up condition. They're called ramp up starters that slowly start the pump. Again, it's all about not having those sudden changes in velocity, especially on stopping a pump. You can get a little bit of a surge when you start a pump, but when you got a pump flowing and then suddenly it stops, that can be a big problem. So this is, like I said, you can have pump control valves. That was kind of the old school way to do it. They were a certain type of valve, but the problem with them was they had a lot of head loss going through them. So you were having to pump, it was basically a money waster as you were adding head to overcome the losses in that valve simply for purposes of pump control. There's a number of other ways to do it now, one of which is simply a check valve that does not allow the reverse flow to happen and prevents that water hammer from occurring. Monitoring pump operations is really about making sure that you are keeping an eye on the facility. You make a lot of investment in these facilities and we have to take care of them. So we're looking for any kind of abnormal conditions. Those could be noises, vibrations. It could be heat. You can walk by a pump, put your hand on it, and if it's overheating, you'll know it. Odors. You can smell when something's starting to heat up or other things that are going wrong with the pump. Suction and discharge head or pressures. We know what they're supposed to be. We know what they normally are. If suddenly it's operating differently than it did yesterday or last week, then perhaps something is wrong that requires some further investigation. Checking our bearing and motor temperatures. Any sudden changes or indications of problems. Like I said, you can sometimes feel that just by hand. They make instruments to check for those type of things, but a lot of times it's simply the operator recognizing that a condition has changed and something needs to be corrected or maintenance needs to be performed before something goes all the way to failure. Monitoring vibration. Again, same concept. Sudden changes on any of these facilities. It operates a certain way for an extensive period of time, and now suddenly it's doing something different. Something is wrong. It can be a potential misalignment of a coupling or the shafts. It can be an imbalance of the pump impeller. There's a variety of different things that can cause vibration, none of which are good for the pump or the pumping system. Looking at our flows, any kind of a change, if we're normally discharging it at 1,000 gallons per minute and absent any other changes, we're now doing 900 or 800 or whatever it might be, something's going wrong. Sometimes it can just be the wear of an impeller and the deterioration of an impeller, and maybe it needs to be replaced. There's other things that can drive it as well, but keeping an eye on the operating characteristics of our system is a clear indication of whether or not something might be going wrong. We can look at our electrical conditions and amperage draws. If we start drawing more current, then likely something is starting to go wrong. Looking at packing leakage is evaluating whether or not the packing is failing or perhaps a seal is failing. So let's talk about pump seals in a little more detail. We're trying to avoid any kind of excessive fluid loss. We're trying to avoid water passing from one chamber of a pump to another. One of the ways we do that is with packing. Packing is a type of pump seal. It's literally packed around the shaft. You can see the packing material right here around the shaft. That is separate rings of, and it's kind of a graphite impregnated cotton. There's other synthetic materials you can use, but it's designed to prevent leakage. Now, when I say prevent, I should say minimize, because in reality, packing and the packing material is designed to have a small, and that term I suppose is debatable, amount of leakage. It helps keep the packing needs to stay lubricated. It needs to stay cool, and the leaking through the packing is how that is accomplished. There are some disadvantages to packing. The friction of the shaft rotating around the packing wears out the packing. It deteriorates over time. Leakage will get worse and worse until suddenly it either has to be adjusted or replaced. The friction of the shaft also means that packing needs to be flushed with large volumes of water to keep it cool. So that's why you have to have some design leakage through the stuffing box, which is where that packing is located. The packing needs to press against the shaft in order to try and control that leakage, which means the pump needs to have a little more drive power. That same friction impacts the operational characteristics of the pump a little bit, so you've got a little bit of power wasted there as well. So there are some disadvantages to packing, but they've been used for a long time. But again, put simply, it's a physical barrier between the shaft and the pump housing so that you can try and maintain leakage. The shaft, to get from the motor to the impeller, that has to go from the dry area to the wet area. And packing is how we try to keep the liquid portions of the pump in the liquid areas of the pump. We've talked about those operational challenges. An alternative is mechanical seals, a newer and really more and more popular way of sealing a pump. Basically, there are kind of three sealing points, we'll call them. The mechanical seal includes a stationary part of the seal that's fitted to the pump housing with some sort of static seal, an O-ring, a gasket clamp, or something like that, that connects the stationary face of the seal to the pump housing, so it doesn't move. And then there's a portion of the seal, the rotary portion, identified as the rotary face in this picture right here, that's connected basically to the shaft. The mechanical seal itself is the interface between them. So you have a stationary portion of the seal and a rotary portion of the seal, and in between them, and it's a really tight space between them, it builds up a little bit of fluid that allows it to rotate without wear and creates the seal. And so you also have a spring, which you can see in this exhibit here, to help keep the two faces, the stationary and rotating face, in very close proximity to each other. So the stationary part is always mounted and connected to the pump. The rotating element is going to be in very close proximity. The again, it's spring-loaded to help keep them close together, and that thin little fluid is what provides your seal. The gap between those two faces is very small. We're talking about smaller than, I saw it measured as 75 times smaller than a human hair. It's basically 1 micron. Because that gap is so tiny, any other particles that could damage the seal faces we try to keep those out. But the liquid that it takes to maintain that fluid, that film, is very small. So theoretically, mechanical seals have no leakage where packing does, but in reality, that thin fluid film that is what actually maintains that seal is a small amount of leakage, but it is so much smaller that it's really visually undetectable. So it's negligible for all intents and purposes. So these do a very good job. It accomplishes the job of restraining any leakage around the pump better than packing does. They last for a very long time. When they do fail, they need to be replaced. You can operate the pump with a failed mechanical seal, and sometimes it takes time to get to them. You'll just have more leakage than you might otherwise have, but it's not going to cause the pump to shut down. So those are a couple different types of pump seals. Again, the mechanical seals, because they have little to no leakage, are becoming more and more popular. Pump bearings. Bearings are essentially what keep the shaft in place and allow it to rotate. It keeps the shaft properly aligned. It helps reduce friction and heat between the rotating surface. So they are an important component of pumps, but maintaining them is a big part of pump operations. Some different types of bearings. You've got ball bearings, named for the rotating element in the bearing, in this case, little balls. This is kind of an exhibit showing the rotation of that bearing element. And so as it rotates, or as the shaft rotates, you can see the balls rotating along the surface. So they're rotating as opposed to sliding. A roller bearing is similar, other than the rolling element is a cylinder, and these are also very typical on centrifugal pump applications. The sleeve bearings are you see them more on the line shaft turbine pumps. It is a kind of cylindrical bearing. It's kind of a plain bearing. It has far less in terms of moving parts. Like I say, the different types for different applications. Another exhibit kind of showing the ball bearing versus the roller bearings. When it comes to maintenance, one of the big issues is lubrication. They have to be properly lubricated in order to function correctly. The lubrication requirements are typically going to be defined by the manufacturer. The timing, the amount of lubricant, the type of lubricant, those should be paid strict attention to. Without proper lubrication, the bearings are going to overheat, they're going to seize, and your pump is not going to be very happy. You can also over-lubricate a pump, and in doing so, you end up causing them, as I said before, you've got your rolling elements, whether it be your balls in your ball bearing or your rollers in your roller bearing, they're rolling, they're not sliding. If they start to slide instead of roll, which can happen if you over lubricate it, then you're going to end up with a deterioration of your lubricant itself, and ultimately the pump is going to overheat. The types of lubrication, you can have oil, you can use grease, depending again on what the manufacturer says is the proper lubricant for that particular bearing. So just a little exhibit showing bearings around. Again, they're all going to be around the shaft on the operating components of your pump. So those are a brief description of some of the operational issues we deal with in pumps and pumping systems. Again, a whole lot more when you take the time, or if you have already, then great. The pumps and pumping class, which goes into a whole lot more detailed evaluation of all things pumping, is a very worthwhile endeavor.